right, so first I want to go over confidence intervals. There are 3 things that you need to do, 3 steps for confidence intervals. So how many steps do you have for hypothesis tests?
5.
5 steps. Everybody on board? Confidence interval, there's really 3 steps. 1, find your point estimate. 2, calculate the interval. And then 3, find your margin of error. If you do it by hand, then steps 2 and 3 will be flipped. You'd find the margin of error first, and then you'd find the confidence interval. Everybody on board?
Yep.
But I'm just going to go with the calculator way, so that these are the steps 1, 2, and 3 that you folks would do. And just as a reminder, this is not in the notes, this is just me talking. Remember, the confidence interval is you take your sample, your p-hat, for example, then you subtract your error to get to your lower limit, and you'd add your error to get to your upper limit. Your error is made up of a certain number of standard deviations. So it's your critical value times whatever standard deviation is for that parameter. Okay, or for that statistic, I'm sorry. Proportions versus means. Mustafa, go ahead and read.
Proportion will have an experiment or survey where the answers are yes/no or are/are not a value. What does the proportion look like? 14 out of 92 students, or 28.6% of students, or out of 389 students, 212 are.
Does that make sense to folks? That's what it looked like in a problem. Keep going.
Nowhere is the words sample mean or sample with the mean of or the mean of the sample. So no X bar.
Right, or it might say average. That's a synonym for mean. Or it might give you the symbol, X bar, which is not X. X and X bar are not the same thing. Keep going.
It all comes down to what are you asking in the survey or experiment? What is your height? Are you an English major? How many siblings do you have?
Okay, so yep. Which of these is a proportion? Which of those 3 questions is a proportion? Is the first one, do you want to talk about this with your neighbors? Take 15 seconds with your neighbors. Which ones are these the proportions, which ones are not? Okay. What is your height? What's your height? What's your height? What are these answers?
Numbers.
Numbers. So is this a proportion or a mean? Mean. Does that make sense to folks? Are you an English major? 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 What kind of answers are those? Is this a mean or proportion? Great. How many siblings do you have?
1.
How many siblings do you have?
2.
How many siblings do you have? Siblings?
1.
Siblings?
1.
What kind of answers are those? So is that going to be a mean or proportion? Mean. Everybody on board? Okay. And again, you got to think back to not what question am I asking you, but what question did the researcher ask the people, the subjects? Right? If it's a cat, you're going to ask the cat, how much do you weigh? Right? Make sense? Okay. I know, but so someone would have to answer for the cat.
Yeah, I'd be very shocked if the cat told me how much it weighed.
Yeah, I know. They don't do that. They do say things like, I am pissed off at you. All right. Confidence interval or hypothesis test. Again, how do you tell the difference? Confidence interval will always say estimate or confidence interval. Everybody on board? Always. If it doesn't say that, it's a hypothesis test. So the easiest way to tell what's a mean or a proportion is a mean will always say mean and standard deviation, right, or average and standard deviation, or give the symbols for that, or it could be in disguise. It could be a number, a set of numbers. How do you tell if it's a proportion? It doesn't. How do you tell if it's a confidence interval? It says confidence interval or estimate. How do you know if it's a hypothesis test? It doesn't say confidence interval or estimate. That's kind of the easiest way to tell. It's a hypothesis test if it doesn't say estimate or confidence interval. That's kind of your surefire way. And also hypotheses usually have phrases like test, claim, evidence, conclude, but not necessarily. Okay. One sample or two samples, again, it's not just you have two means. It actually says sample or selected or surveyed twice. There should be two groups that you surveyed. Does that make sense for folks? So that's kind of the key part. Because sometimes we'll give you a mean. We'll say that the Pew Research Group has a mean of blah, 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 and then we took a sample. But you don't have two sample sizes. Does that make sense or so? So you should have two sample sizes as well. There was that one thing where we had the 50 colleges, men and women, but you had two sample sizes. There's 50 in both cases. All right, everybody kind of got a handle on that? Two samples means you have two actual samples. And you should have two ends, even if they're the same end. Okay. On exams, for your hypothesis test, I want these 5 steps. We've talked about them a million times. I'm not going to talk about it again because I don't want to bore you. But those are the 5 steps you should have. So now we're going to spend some time. Don't solve, just identify what kind of problem it is. Is it a proportion or a mean? Is it a test or a confidence interval? And identify some of the main variables. So let's get a reader for the first one. How about Devin? Go ahead.
A medical investigation claims that the average number of infections per week at a hospital in southwestern Pennsylvania is 16.3. A random sample of 10 weeks had a mean number of 17.7 infections. The sample standard deviation is 1.8. Is there enough evidence to reject the investigator's claim at alpha equals 0.05?
Great. So here's the thing. There's going to be roughly, okay, so there's going to be 8 problems that are, here's a problem, you need to do something, and they're going to be roughly worth, on average, 10 points, right? Anywhere from like 6 to 11 points, 6 to maybe 11 or 12 points. And then there's going to be a bunch of these multiple choice questions, maybe 6 to 8 of those. But these ones here, people will mess them up because they'll do a hypothesis test on a confidence interval or vice versa. They'll treat a proportion like a mean or vice versa. And those are, obviously, you'll lose like almost all your points on that, right? Pretty much all your points on that. So it's really important because once you know what kind of problem it is, you guys are all good to go. You got your you got your step 1, right? And you got your step 3, and then 2, 4, and 5. Or if it's compensable, you have your 1, 2, and 3. So people don't have a problem doing the problem once they know what kind of problem it is and they know what to do. So we're going to spend a little bit of time today, maybe 20 minutes today, going over what kind of problem it is. So with your neighbors, try to figure out what kind of problem it is and identify the variables you have. Okay, let's take a look. Is it a mean or a proportion? How do you know it's a mean?
Standard deviation and it says.
Yeah, it has the words mean and standard deviation. Good. Is it a confidence interval or a hypothesis test?
Hypothesis test.
How do you know that? There's no estimate. Does anyone see that? Estimate or confidence interval. Does everyone follow that? If you look for the word estimate, it is not there. If you look for the phrase confidence interval, it's also not there. Also, what are the other cues?
Average and claim.
Has claim and has evidence. Is everybody on board with that part?
Mm-hmm.
Okay, so this is a hypothesis test. How many samples are there?
1.
You sure?
Yes.
Yes? Okay, good. You're sure. Perfect. So it's 1 sample. Good. So it is a mean, it is a hypothesis test, is 1 sample. What calculator function will we use?
T-test.
T-test? T-test. All right, so everyone try it and pop in what you think that you should pop in. And what's the claim? What's the claim? The average number, so if it's a mean, it should be mu, not p. Everybody on board? Mu is what?
16.3.
So is equals 16.3. So that means that you're in your t-test. What are you going to use for the symbol?
Equal.
Well, it would be
Not equal to.
not equal to.
The H1.
Because remember, your h1 is always going to be not equal to when your h0 is when your claim is equals.
I got lost when we were in the crowd.
Okay, so I'm going to go to stat. I'm going to go over to test. And I want the t-test. And do I have data? Do I have a whole bunch of data, or do I have statistics? Statistics. Okay, great. So my mu naught. What's in my claim?
16.3.
16.3. And my x bar is
17.7.
17.7. Great. My s is 1.8. Great. What's my sample size? N? 10. Terrific. And then my h1 would be not equal to. Oop, lost it. Not equal to. Good. We will calculate that and get. Here's my stuff right there. All good? Okay. Perfect. Next one. Let's get a reader for this one. Laura, you haven't read yet?
Cost of college tuition. A research wishes to test the claim that the average cost of tuition and fees of a four-year college, public college is greater than $5,700. She selects a random sample of 36 four-year public college and finds the mean to be 5,950. The population standard deviation is 659. Is there evidence to support the claim at alpha equals 0.05?
Great. So I need you to figure out whether it is in your groups, mean or proportion, whether it is a hypothesis test or a confidence interval, or whether it's, and how many samples it is. So go ahead and take a minute, 30 seconds with your neighbors, sort it out. Okay, so Taylor, what'd you say? You said to me a second ago, which was?
I thought it was the same as the last one.
Similar. Is it a mean or proportion?
It's a mean.
How do you know it's a mean? So it says average.
Standard deviation.
It is a mean. Is a hypothesis test or confidence interval?
Hypothesis.
How do you know? Again, yep, no average or confidence interval. And again, there's a claim and evidence. Everybody on board?
Yeah.
Good. How many samples are there?
6.
How many samples are there?
Oh, I need some.
One.
There's one sample. So it's going to be, so what are we going to use for our t-test? Yep. Which means we also have to figure out what our claim is. What's our claim? Everyone find the claim, find the claim?
57,000 or 5,700.
Is it P or mu?
It's
Mu.
mu
Mu is what?
greater than 5,000.
Greater than, yep. Okay, everybody bust out your calculator, do it, find it. Do it, find it. Okay, let's take a look and see what we get.
This one, right?
So, we did stat test, t-test, statistics. Our mu naught was 5,700. Our x bar was 5950 with a standard deviation of 659. My n was 36, and we said, what was our mu naught? What was our last one? Our claim?
Greater.
Greater than. Last one. So we ended up with a t-value of 2.276 and a p-value of 0.0145. Great. Next one. Una, you haven't read yet.
A researcher claims that based on the information obtained from the Center for Disease Control and Prevention, 17% of young people ages 2 to 19 are obese. To test this claim, she randomly selected 200 people ages 2 through 19 and found that 42 were obese. At alpha equals 0.05, is there enough evidence to reject the claim?
Great. I'll give you folks 15 seconds with your neighbors, starting right now. Go.
One prop, pizza.
Okay, is it a proportion or a mean? I think it's a proportion. There's a percentage, yep, and there's no what?
Standard deviation.
Yeah, no standard deviation. Does that make sense? Everybody on board? That's the easiest way. There's no standard deviation. Or mean or average. Is it a hypothesis test or confidence interval?
Hypothesis test.
I think it's a hypothesis test.
There's evidence in the claim.
Yep, there's evidence and there's a claim. Everybody good? All right, so what are we going to use for this one then? Yeah, one prop Z test. Everybody on board with that part? Good? Let's try it. Everyone do it quickly. Do it.
Would it be not equal to?
Yeah, 15 seconds. Oh, what's our claim?
Not equal to?
Yeah, our claim is that they are. So my claim is that P, not mu, P is 0.17. So that means that it's going to be not equal to. Okay, so this one, you're going to do one prop Z test. You're going to put in 0.17, 42, 200, not equal to. Right, so stat test, one prop Z test.
Why do we use one prop Z test?
Because it's one proportion.
There's one proportion.
Yep.
So what is
If,
it?
if you had two proportions, you use two proportions.
So what would just be the Z test?
Z test is for means. Yeah. So proportion. So that's a great question. Z test, we never use Z test because that's for a mean when you know your population standard deviation, which we never do. It's unrealistic. So that's the one we never, ever use. Z interval and Z test we never use. If it's a proportion, you use one prop or two prop. Yeah, great question. Thank you for asking that. 0.17. That's a super common mistake. So I'm glad you're bringing that for folks because that way all those people at home will not do that, and they'll have you to thank for pointing it out to us. Generations. Well, at least this semester. All right. So there we go. We have our Z-score and our p-value. All right. Great. Next one. Isaiah, have you have read yet? Have you?
Not bad.
Oh, you have?
Yeah.
Michael, have you not read?
Not.
Okay, great. Go ahead.
The Medical Rehabilitation Education Foundation reports that the average cost of rehabilitation for stroke victims is $24,672. To see if the average cost of rehabilitation is different at a particular hospital, a researcher selects a random sample of 35 stroke victims at the hospital and finds that the average cost of their rehabilitation is $26,345, with a standard deviation of $3,251. Construct a 99% confidence interval for the true average cost of rehabilitation.
Great. 15 seconds. What kind of problem is this? All right, is this a mean or proportion?
It's a mean.
Mean. How do you know it's a mean?
So we have standard deviation.
Yeah, because it has the word standard deviation here somewhere.
Bottom.
Oh, there we go. Standard deviation. Everybody good with that part? Also says average. It's another way. Is it a hypothesis test or confidence interval?
Interval.
How do you have the confidence interval?
It says confidence and construct a confidence interval.
Yep. Confidence interval. Great. How many samples are there?
35. Oh, one sample?
One sample. Random sample of 35. There's only one sample. Is everybody good with that part? Okay, so what, everybody do this one. It is a mean, it's a confidence interval, one sample. All right, so it is a mean, so means we use what? T, and it's a confidence interval, so we should use interval, should end in interval. So it starts with T and ends in interval. So that would be
Very few.
the interval. Okay, so let's see what we got here. So I'm going to go to stat test T interval. Again, we never use the interval ever. And we want, let's see, we have statistics, so my X bar is 2, 6, 3, 4, 5. My S is 3, 2, 5, 1. My N is 35. My confidence level, we want a 99%. And I'm going to calculate that. Thinking a long time. And I end up getting 24846 to 27844. Everybody good with that part?
Yes.
Okay. Good. Next one. Vaccination rates. Starting all over again. Justin, go ahead and read.
In a nursing home study, the researchers found that 12 out of 34 small nursing homes had a resident vaccination rate of less than 80%, while 17 out of 24 large nursing homes had a vaccination rate of less than 80%. At alpha equals 0.05, test the claim that there is no difference in the proportions of the small and large nursing homes with a resident vaccination rate of less than 80%.
Good. All right, so 15 seconds. Is this a proportion or a mean? Confidence interval hypothesis test. One sample or two samples?
But it's still proportional. It's confidence interval, it's not a hypothesis test.
You say it's less.
So it's 2 packs.
Okay, so is this a mean or is this a proportion?
Proportion.
How do you know it's a proportion? It says proportion?
It's in the proportions of the.
Yeah.
As
Proportion.
a percent.
Well, it's
What?
it's out of. Does that sort of make sense? There's an out of. And there's no mean.
Or standard deviation.
Yep. No mean or SD. All right, next. Is a hypothesis test or confidence interval?
Confidence interval.
How do you know it's confidence interval?
I don't see test or claim in there.
Oh, confidence interval is the flip. Confidence intervals always have to say estimate or confidence interval.
Oh, okay.
So let's find the word. Let's find the word estimate.
So it doesn't say those. So then it's a test?
Right. So there's no estimate or confidence interval. So that means it's a hypothesis
Oh,
test.
test to claim. I see it right there. I missed it.
And also there's a test to claim.
Oh.
I missed that.
Yeah. So the confidence interval and means are the two things that always have a Q. So the mean will always say mean or standard deviation. The confidence interval will always say confidence interval or estimate.
Okay.
The other ones are the absence of them. How many samples are there? Yep, 2 samples. Okay, so everybody do the, do your calculator thing for this. 2 samples, proportion, hypothesis test. Okay, let's take a look. So I'm doing a 2 sample t-test. There's 2 samples, two proportions. So stat test, 2 the proportions, so 2 prop z-test. And my x bar, it's 12 out of 34. And it is 17 out of 24. And it is, what was the claim? The claim was that there's no difference, so not equal to. Everybody okay with that part? Mm-hmm. So we end up getting a z of, I should probably go through that again. Stat test, 2 sample, 2 prop z test. So here we have it, and then we end up getting a z of negative 2.667, and a p-value of 0.00767. Okay.
On the test,
Yep.
say if we accidentally choose the wrong,
Then it's all kinds of trouble.
is there any indicator when you're entering the numbers in the
That's-
problem
So the thing is,
or not?
when you, on step 3, you're saying what test you did and what you input into the test.
Oh, yeah.
Yep.
Well,
So,
can you catch yourself?
so hopefully as you're writing it down, you're like, oh, it's asking me for the wrong things. And also, it will say at the top what kind of test it is. So if you look at it, it says 2 prop z test at the very top.
Mhm.
So if it's asking you for a mean and you have a proportion, then you're like, wait, something's wrong here. Yeah, great question. Go ahead and read this one while you're here.
Me?
Yeah.
Okay. According to payscale.com, the average starting salary for a nurse practitioner is $79,500. A researcher wishes to test the claim that the starting salary is less than $79,500. A random sample of 8 starting nurse practitioners are selected, and their starting salaries in dollars are shown. Is there enough evidence to support the researchers' claim that at point 1 assume?
Alpha. Sorry. Alpha.
I was like, I
Yeah.
got that wrong. At alpha, at point 1, assume the variable is normally distributed.
All right, folks, is this a mean or proportion?
Mean.
Mean. How do we know it's a mean?
Because we have data.
Yep. Oh, we have data. Nice. Excellent. Is it a confidence or hypothesis test?
Evidence, yeah, so there's evidence, so it's a hypothesis.
Okay.
Claim.
Hypothesis test because there's evidence.
There's a claim.
Yep. It doesn't say estimate or confidence interval, and there is a claim, and there's evidence. Okay, great. How many samples are there?
One sample.
Not the sample size. How many samples are there?
1.
Oh.
1 sample, right? There's only 1 bit of data. So I would do, so everyone figure out how I would do this on the calculator.
Subtract.
Put in this 2 and 3 and then you subtract and eliminate this one.
Okay, take a minute. Take a minute. Get it done.
But there's no easier
But isn't L1 give you like the difference?
But it's,
Okay, so how many samples do we have? 1 sample. So it's just 1 sample. Everybody on board? So if it's 1 sample, we're going to do what? T-test. Okay. So here, I've got my 1 sample. I put it into list 1. All right, I put my data into list 1, and then I'm going to do stat, test, t-test, and we're going to pick data. right? Because we have data. So data, our mu naught is 79,500. List one of each, and our claim was less than, so I'm going to go to less than. Calculate. Good. So then we end up getting, what was it, 79,500, L1, this is an L1, 1 less than. And y'all got a t-value of negative 1.77 and a p-value of 0.0597.
Now, why did we only put it in L1?
Because there's only one list of data.
Okay.
Is this before and after? Does that say before and after, or left and right, or first group and second group?
No.
So I was going to see the difference. So yes, they're matched up, but they aren't labeled as the first group and the second group. Right? They're not two groups. It's just one group. How many people? A sample of 8 starting nurses. My sample size is 8. There's 8 of them. There's just one sample. Yeah. So that's why we're doing this one today for 2 reasons. One is so you recognize it's not a dependent one because there's only one sample, and that you understand to put the data, right, do the data option of t-test and not the stat option. This is data. Okay. All right. Next. Yeah, go ahead and read.
A researcher wishes to be 95% confident that her estimate of the true proportion of individuals who travel overseas is within 4% of the true proportion. Find the sample necessary if, in a prior study, a sample of 200 people showed that 40 traveled overseas last year. If no estimate of the sample proportion is available, how large should the sample be?
Great. 15 seconds with your neighbors. What kind of problem is this? Okay, so is this a proportion or a mean? Proportion. It says proportion. Good. Is it a hypothesis test or is it a confidence interval? It's a confidence interval. So, how do we know that? Because it says we want to find, there's an estimate. Does that make sense? Okay. Now, here's the thing though. If it says find the confidence interval or find the estimate, there should not be a question. So there is a question. What's the question?
How large
should the sample be? So under confidence intervals, what kind of problem, sub-problem is this? What kind of subset problem is this under confidence intervals?
Find n.
Find n. How large should the sample be? How large should n be? N. Does that make sense? This is a find n problem. So everyone look on your yellow sheets and find what formula you use. What formula? N equals yellow sheet, yellow sheet, yellow sheet.
No, that wasn't right.
Proportion confidence interval. It's under proportion confidence interval. You should have circled it because this is one of the things I told you to circle.
Oh, yeah.
P hat plus or minus.
Yeah, it's p hat. Whoa, wait, what?
Wait, no. P
P hat and Q hat, parentheses, critical value over E squared.
E squared times p hat times q hat. Everybody got that?
Yeah.
Okay, so there's 2 parts to this. The first one would be prior study. 200 showed that 40 traveled overseas. You're going to use that to find your p hat and q hat. And then here, if I'm asking you to find n, that means I didn't give you n, which means I have to have given you the error, the critical value you find from your confidence level. You look it up in the table. Your error,
You can solve.
what's the error? What's the error? I have to give them the problem. Where in here is the error? That's the last thing we're doing today. What's the error?
Solve the confidence and subtract from the
Yep. You find within, you find your error. Does that make sense? Your error is 0.04. because it's where the within is. In other words, the guy says he'll guess your age within 3 years. He gets 3 years this way, he gets 3 years that way, right? Within. That's your error. All right, I'll see you folks on Wednesday. We'll do more of these.